Welcome to another lecture of Smart Pathshala. So in this lecture, we will see some problems on differentiation. Okay. If you guys have not gone through the videos which describes about the different formulas of differentiation, then I would suggest you guys to please go through them and then come in this video. Okay. So let's start. This problem says if we have one condition. What do we have? We have x into 1 plus y into root over 1 plus x is equal to 0. Right? From here, we need to prove that dy dx is equal to minus of 1 by 1 plus x whole square. Right? Now here, one important condition is that x not is equals to y. Let's see why this is an important condition. Okay. We can write x into root over of 1 plus y is equal to minus y into root over of 1 plus x. So what you need to do is to square on both sides. Okay. So what you will get is x square and 1 plus y square and 1 plus x. So what you have is x square plus x square y is equal to y square plus x square. Okay. Now what you need to do is take this y over here. So you can get x square minus y square and xy square minus x square y. Perfect. So what you have is x plus y into x minus y, and taking xy as common, here you have is y minus x. So from both of the sides you can cancel x minus y. This is only possible when x is not equal to y, right? Okay. So after cancelling these two terms, what we have is x plus y is equal to minus x y, right? Now from this equation, we would like to find out y only, right? Okay, let's find out y. So from here, if you can recollect this y, that is y plus xy, and here you have minus x, or take this y common, you have this term. Similarly, if you get this in explicit form, you will have 1 plus x. Now differentiate here with respect to x. When you differentiate here with respect to x, what you will get is ddx of u by v rule, right? So we know this rule, right? Obviously. So this rule says 1 plus x whole square, then 1 plus x, ddx of minus x. So you have minus 1, minus of minus x, and then ddx of 1 plus x. So what you have is 1, right? Perfect. Now expand this. You will have minus 1 minus x plus x, right? So what you have is 1 plus x whole square, and hence this will give you the required result, right? So this is what you need to prove, right? Let's see the next problem. Okay, so in this problem, we have been given one trigonometric equation, and we have to prove that dy dx is equal to y by x, right? Now let's start from the given condition. Okay, so we are given cos inverse of something is equal to this. Now, what we will do is that we will divide the numerator and denominator by the same factor, and the factor is x squared, right? So what we will get is 1 minus y by x whole square divided by 1 plus y by x whole square, and that will be equal to tan inverse of a, right? On the next step, we will obviously get as 2 tan inverse of y by x. Please go to the trigonometric formulas for deriving this formula, right? We will have tan inverse of a, and then you have tan inverse of y by x is equal to half of tan inverse of a. Again, what you have is y by x is equal to tan of half tan inverse A. Now at this step we will differentiating with respect to x. What we will get is x square x dy dx minus y into 1. That will be 0 because this term is nothing but constant. Because A is constant, so tan inverse is constant, half tan inverse is constant, that means the full tan of that half of tan inverse A is constant, right? Okay. Now here, when x goes this side, you will have x dy dx minus y is equal to 0, and hence you will have dy dx is equal to y by x. So this is the required solution. This problem can be solved in another method also. Okay, so let's solve the problem. Okay, this the second technique is for those who don't know this formula, how to derive from cos inverse through tan inverse. Okay, and let's do that technique. Okay, so in this technique, what we will actually do is we will transfer this cos inverse on the right hand side from the left hand side. So what we will have is cos of tan inverse A, right? Okay. Now let cos of tan inverse A be certain number, suppose lambda, right? So what I will have is x square minus y square plus y square is equal to lambda. Okay, now that's again true. Now we just do one thing, reciprocate both sides. What you will have is this term. Now apply componendo and dividendo process. So what you will have after applying componendo and dividendo is quite this one, surprising, right? Okay, and here you will have 1 plus lambda, 1 minus lambda, and on the next step you can write x square by y square is equal to 1 plus lambda, 1 minus lambda. Just have to write by applying componendo and dividendo. Okay. Now at this step you differentiate. Okay. After differentiating, what you will have is y square whole square. On this side you will definitely get 0 because you are derivating a constant term, right? Okay. Now you will have y square over here and then 2x minus x square and 2y and dy dx in this term. On the second line, what you will have is 2x y square minus 2x square y and dy dx will be equal to 0. Right? Now, this problem will be clear from the last line we have obtained, that if you take this 2xy common from the expression, what you will get is y minus x dy dx is equal to 0. Now from this line you can obviously write dy dx is equal to y by x. So this is the solution of the given problem. Let's see the next problem. In this problem, we have been given one expression that cos y is equal to x into cos of a plus y, right? And this, maybe this is a little bit visible or this may be blurred, but it's written here cos a not is equal to plus minus 1, right? Okay. The question given here is cos y is equal to x into cos of a plus y, and we have to prove this thing, that dy dx is equal to cos square a plus yy sin a. Now, I want to grab my viewer's attention to the fact that the right hand side of this derivative does not contain of any term that is x, right? It only have y. Now we know the relation between dy dx and dx dy is the reciprocal of each other. We will apply this logic in this problem, right? Okay. So let's descend down from whatever is given in the problem, right? What you need to write is write x in terms of y. So you have x is equal to cos yy cos a plus y, right? So that's a little bit strange. Okay, no problem. So now differentiate x with respect to y in this case, right? Now when you differentiate x with respect to y, what you will get is dx by dy is equal to cos square a plus y and cos a plus y sin y. You will get a minus sign over here. Then you will have minus cos y sin a plus y and plus sign over here because of you are getting one minus sign in this location, right? Now what you will definitely have is, now look carefully, here you have sin a plus y cos y minus cos a plus y sin y. So that is actually a formula of sin a plus y minus y. So in this equation, what are you having is sin a by cos square a plus y. So what you have is dx dy. Therefore, so you just reciprocate this term according to this formula that dy dx is actually reciprocal of dx dy. So you will also reciprocate this one to get cos square a plus y sin of a. So this is the required solution for the given problem. Let's see the next problem. Okay. Now we'll solve a special type of problem when we have two functions raised to the power of another, right? We'll have this type of function f of x and raised to the power gx, right? Okay. Now what we will do in this situation, you just put over a y in this situation and take logarithm on both sides, right? So see, this is a technique how to solve or differentiate any function where you have two functions raised to one another, right? Okay, so what you have to do is to take logarithm on both sides, log of x to the power sin x, and what you have is log of y and sin x log x. Now differentiate. At this step you need to differentiate. After differentiating with respect to x, what you will get is 1 by y, definitely, and then you will definitely have dy dx a term in this position. Now again, you will definitely have u into v rule, and you will have sin x by x plus log x will be kept constant, and then the dx of sin x is nothing but cos x. Now again, from here dy dx, see this y is in denominator, so obviously after cross multiplication this y will be going here, right? Okay. This y will be on that side. So what is actually y? Why we have written x raised to the power sin x. So you just have to substitute x to the power sin x, and then you have 1 by x sin x plus cos x log x. So that is the solution of this types of problem, and in this way, by putting logarithm on both sides of the expression, you can actually solve, you can actually differentiate any type of expression of this form given to you. Let's see the next problem. Okay, in this problem, the given condition is this one, and what you need to prove is this, that is differentiate y with respect to x. You will have this term. See, this RHS term does not contain any term that is of y. So which means actually we need to convert this implicit function x to the power y e to the power x minus y into this implicit function into an explicit function. Okay, so how actually we will do it? Now take the logarithm on both sides as we have mentioned on the earlier problem, right? So after taking logarithm, what we will have is obviously log e to the power x minus y, and that will descend into x minus y. And here we will have y log x is equal to x minus of y. Take this y on the left hand side so that you can have y taken common, and that's 1 plus x and x. So what you have is y is equal to x by 1 plus log x. So here we have got the explicit form. So now what you need to do is only differentiate y with respect to x. So let's do that. Y is equal to x by 1 plus log x. So what we have obtained in the previous step is equal to y is equal to x by 1 plus log x. Okay, fine. So after differentiating, we will have dy dx, and here obviously u by v rule, and you will have 1 plus log x whole square and 1 plus log x and 1 obviously minus x into 1 by x, right? Okay, this symbol is nothing. Okay, 1 by x. So what you will have in this situation is 1 plus log x minus 1 plus log x whole square. What you will have is actually log x by 1 plus log x whole square. So ultimately what I actually obtained is dy dx is equal to log x by 1 plus log x whole square. So this is actually the solution of the given problem. I hope you have got the inner meaning of this problem or the technique how to solve it, right? If you have any doubt regarding this class, please let us know in the comment section, right? Okay, now let's move on the next problem, or maybe the last problem of this session. Okay, in this problem we have been given this condition, that is x to the power m into y to the power m is equal to x plus y whole to the power m plus n. Now what you need to prove is dy dx is equal to y by x. Now we have mentioned earlier that this type of problem can be solved by taking logarithm on both sides. Okay, let's do that process again, right? We have x to the power, sorry, this question it will be n actually. Okay, so x plus y whole to the power m plus n. Now repeating the steps again, we'll have log of x to the power m, y to the power n is equal to log of x plus y whole to the power m plus n. So when you segregate these two terms, right, so what you will have is m log x plus n log y is equal to m plus n log x plus y sorry, And again, if you differentiate this equation, what you will have is m by x plus n by y dy dx, and obviously at this term what you will have is m plus n by x plus y, and by the chain rule you will have 1 plus dy dx. Okay, so what you need to do in this situation is that just separate this dy dx term, right? Okay, now let's do that. So you will have m by x over here, and then m plus n by x plus y, and when you take this dy dx as common term from this one and this one, you will have obviously m plus n by x plus y minus n by y. So again, what you have here is x into x plus y, and here mx plus my minus mx minus nx. Nice. So in here you have dy dx is equal to y and x plus y, my plus ny minus nx and minus ny. Okay, so there is many things going on over here, so just cancel out one by one. Over here you have mx and mx is cancelled out. So here see what we are left out with. So after doing so much of mathematical jugglery, what we are left out with is actually my minus nx, my minus nx, and divided by x, and over here we will have y in the denominator and my minus nx in the numerator and dy dx on this side. So again cancel out this both numerator, and what you will have is 1 by y dy dx. I am writing this term over here and this term over here. On the next line obviously you can write boldly dy dx is equal to yx. Today's class of Smart Pathshala Mathematics section. See you in the next video. If you have any doubt, please let us know in the comment section. And we know that maximum of you guys are watching. Still, you didn't subscribe to our channel. If you like our channel, then please subscribe and tap on the bell icon so that you can get notified whenever our new videos comes. Thank you. So see you in the next video.